Good morning everyone, my name is Shaurya Pathak.
And my name is Arpit Bishnoi.
Today we will presenting our project based on weather forecasting using machine learning in Python. We first went to GitHub to get the data, and after getting the data we opened this data in Jupyter Notebook. We begin by importing essential libraries, pandas and numpy for data handling, Matplotlib for visualization and sklearn for building machine learning models. In the first few lines of code, we loaded the dataset using panda.read_csv function and displayed the first few rows with the head function. This helped to check what columns were available, like temperature, pressure, humidity, and date. Next, we performed data cleaning, removing missing values using dropna function and checking data types into info functions. This ensures that the model does not face any issue during training. After that, we use describe function to get a statistical summary. This helps understand the range, mean, and distribution of temperature and other variables. Then we begin the data visualization part to identify relationships among features. The first graph was a scatter plot between minimum temperature and actual temperature. Using plt.scatter functions, it showed a positive correlation. As minimum temperature increases, the overall temperature also increases. This confirmed that the minimum temperature is an important predictor. The second graph compared heat index and temperature. The points formed an upward trend indicating that higher heat index values lead to higher actual temperatures. The third graph plotted pressure versus temperature, showing a weaker relationship suggesting that pressure does not strongly influence temperature predictions. The fourth graph displayed actual versus predicted temperature values. After model training, the points were close to the line of equality, meaning the model performed and produced accurate forecast.
Moving forward, we prepared the dataset for modeling. We split the data into training and testing sets using train_test_split function, typically with 80% of training and 20% of testing. Then we created two machine learning models. First, a linear regression model. Second, the random forecast regressor. Both models were trained using the .fit function, and prediction were made with .predict function. After training, we evaluated the models using metrics such as mean square error and R-square score. These values helped measure how close the prediction were the real data. Finally, we visualized the result using Matplotlib plotting the actual versus predicted temperature. The closer the points were to be the diagonal line, the better model accuracy. Overall, the random forecast model gave slightly better performance because it captures non-linear relationships and variations better than linear regression. In conclusion, this project demonstrates the full workflow of forecasting system, from data cleaning and visualization to model training, testing and prediction. The scatter plot helped in understanding relationship, while the final comparison plot visually proved that the machine learning model can effectively forecast temperature. Thank you.